Good morning to everyone. Welcome to the Institute for Economic Research. This time, we welcome to Dr. Shimelis. He is currently a professor at the Florida International University in the United States of America. He's going to give us a really interesting um, conference about climate change and water access. At this time, we are now facing global problems, and one of these is water scarcity. With climate change, we are having a strong impacts. Climate change not only does it affect people's well-being, but also water access and the implementation of public policies for water sustainability in our country. Thus, it's extremely important to develop integrated approaches for water resource management in the face of climate change in Mexico and at the worldwide level. That's why I am very happy to having Dr. Shimelis um, to discuss these issues, very important issues for Mexico City also, in the Institute for Economic Research of the UNAM. Thank you, Dr. Shimelis. You are very welcome to our institution, and you have the word.
It's a great honor for me to come here in Mexico and just to meet my longtime colleague, Dr. Armando, and also to see this institute in Mexico. Mexico is my really my favorite, one of my favorite places, and I've been here previously, 10 years ago again, maybe 7 years ago, and me and Dr. Armando, we know each other maybe for the last since 2011, I think it's for the last 11 years, and we do the collaboration and the research and training, and also some seminars and so on. So today I just came here. I'll be here this couple of oh. So today's seminar, I would like to introduce some of my activities globally and some of the experience we earned, and also what experience that also we can share to our colleagues here. A kind of This is a platform for sharing experience from different parts of the world. So my title is Integrated Water Resource Management for Sustainable Development. So I'd like to introduce that the different tools what I've been using to achieve my overall goal on sustainable development, mainly focusing on integrated water resource management. So my overall objective was just to develop an integrated surface and groundwater modeling system that can serve as a tool, as decision support tool for environmental and water management operations, land use change impact assessment, climate change impact assessment, and also implement alternative options or management strategies for sustainable water and environmental resource management that can help and contribute for sustainable development in regions like here in Latin America and also Caribbean and other parts of the world. So when I to achieve some of my water resource and environmental management system, I mainly use tools, develop models that can serve as decision support tool, as I said earlier. And there are a lot of hydrological models, watershed models that can quantify water resource allocations, water resource availability that can be used for flood control, to understand the impact of climate change, to understand the impact of land use change, and also to also assess the best environmental pollution control strategies and so on. So I have been using several tools, but I'm not sure if some of you are familiar with modeling tools. I know Armando, he has attended some of my seminars, and also he knows my publications. So I use like tools called soil and water assessment tool. That's for more of watershed level or catchment level watershed system modeling system. And there are also some hydrodynamic and also numerical models I use, and also GIS and remote sensing. That's one of the key tool to that was used for water resource applications. And by the way, tomorrow and after tomorrow, also we'll have a kind of an introductory training for graduate students and also anyone interested. So GIS and remote sensing is also one of them as a tool for water resource and environmental assessment. So we also, so for model also we use different tool like calibration and validation tool, because once you develop a model, you also need to verify that that model result is acceptable. So for that, I don't go in detail. This one more technical, but to tell you that you don't just use as a computer software or model, just input and output, but you must try to assess how the model prediction uh, correlates, agree, or in a good agreement with already existing data. So that way you can use for the model for developing different management strategies or to study the impact of climate change or land use change. So for model development, as I mentioned earlier, you develop the model, you calibrate the model, and you also, once you calibrate and validate the model, you start to use a model like for water balance assessment, for assessment of climate change, assessment of land use change, and so on. Once you have the tool, you can use that tool for several applications. So the main challenge for modeling and water resource, especially developing an integrated water resource management system, is the data. Because model is nothing without the data. It's a kind of a tool, but the main driving force for the model to work is the input data. So, so many of the input, many of the models they require like GIS data, example elevation data. We call it digital elevation model because elevation is the movement. The water flow depends upon the slope. We use land use change because land cover has a great role on the flow of water and sediment. Soil is an important also factor because, especially for, thank you, for watershed management, that any application or any intervention requires the right assessment or knowledge of the soil type you have in your watershed. So soil, and also especially for some hydrodynamic models, you need also the bathymetry of a lake or rivers and so on. So land use, soil, and slope layers are key factors for setting up your model. The other important parameters, and if you have soil map, that you also depend on some soil properties, especially some physical properties. Maybe some of you already know, like soil layers, what type of soil layers you have, the texture of the soil, or depths from the surface, bulk density, and available water holding capacity of the soil. These are some of more soil physics parameters or soil parameters, physical parameters that really determine the infiltration of water into the ground. That is the major data input for watershed management and also for simulation of the model for water-related activities is the meteorological data, like precipitation, air temperature, solar radiation, wind speed, and relative humidity. These are some of the soil parameters, but especially the precipitation, rainfall, and temperature, also evapotranspiration, is the key or the driving force for the hydrology of a watershed. So you need also hydrological data like the river runoff data or sediment measure data that help you to calibrate your model that can be used to verify the performance of your model. And the land management data, that's the key because how the land is managed, is that maybe either for agriculture, for irrigation, and so on. So to have a kind of detailed information about your watershed and land management system is the key to set up and define your modeling system. So today, just I would like to show. I mean, I just gave an overall overview of what tools we have been using, why having the reason we need to have a model. But using some models, I would like also to share some of some international applications of some models. And like for example, this is integrated water management for the Yalas and Hope Watershed Management Unit in Jamaica. And I have two watersheds in Jamaica, Yalas and Hope River Basin, which is this project was financed by IDB. And so the main objective was identify and apply sustainable modeling platform for microcatchment within Yalas and Hope River Watershed Management System. So their local governments, they would like to know on those watersheds to have the most priority areas for intervention. So for that, what we did, we developed a model, watershed model for that watershed, and able to identify based on the output of the model, try to see the most key priority areas for intervention that help for the decision makers where to implement new interventions. And in fact, also there are a lot of other, but capacity building also one of the key uh, uh, component of this project because once you implement a tool for a watershed or for any area, it's also a good idea to build the experience of the local people. So they will be there managing the watershed and activities. So through this program, I was also able to train people there, experts. There are very good experts there. So about the GIS and modeling system, so that after we finish a project, those experts can also continue doing that program. Another project also in Jamaica, but in a different watershed. We call it the hydrological modeling, climate change impact, and land use dynamics in Wag Water River Basin. So it's in Wag Water, and the main objective was to develop a tool for that watershed. So what I learned from there that they have small dam that supply water for the part of Kingston city. So that dam watershed, that reservoir contribute about 20 or 30% of the water demand for Mexico City. Sorry, for Kingston City. So they start to the need to assess the sediment movement in the watershed so that they can make appropriate intervention to avoid siltation of the dam. So what we did in model is that we assess the upstream of that dam, small dam actually. That was the objective. So they need a kind of tool to be able to identify the impact of land use and climate change for that watershed, and that can be used to safeguard the dam because that dam is the water supply for a certain percentage of population in Kingston City, the capital of Jamaica. So this is, for example, one of the model results. You can see that this graph shows you how the model predicts the river flow or runoff as compared to pre-existing data. So that's how you verify the model performance. How do you assess if the model is doing good or not? So looking into this graph, you can say that the model prediction is ideal for that watershed. Another project we have also human impact to coastal ecosystem in Puerto Rico. It's remote sensing, hydrologic, ecologic, and socioeconomic assessment, which is mainly with management implications. We have two watersheds in Rio Loco and Rio de Manati watersheds in Puerto Rico. And the main goal of this project was kind of to conduct an interdisciplinary study using sound mapping technologies and hydrological modeling, mainly, in fact, related to land cover and land use changes. And this project combines output from field measurement, ecological modeling, and economic evaluation. Also, because there are some economics was part of this project, which is financed by NASA, to assess degradation of coastal and marine ecosystem. That was the main goal of this program. You can see this is also time series comparison between measured and simulated data for Manatee watershed. It shows me that my model works perfect here. So that's really this type of assessment gives you kind of confidence to use the model for any application and decision-making system. Another project we have water availability, water quality, and integrated water resource management system for northern Haiti. So we have one watershed, a Trudeau North watershed in northern Haiti. Also, that program was sponsored by IDB, Inter-American Development Bank. So one of our goal was to analyze an assessment of the institutional and governance of the governance framework for integrated water resource management. And we try to assess the data gap and what's missing so that we can also propose for future data collection. And we also implemented an integrated modeling system to assess the watershed and the upstream and the downstream flows and water system. And finally, the final goal was to develop an integrated water resource management system for that northern watershed, because the government of Haiti was trying to construct some kind of industrial park in that coastal region. So before they make a decision, they would like to understand how the flooding and other environmental behavior of that watershed. This is in fact one of the projects we have in the US, surface water modeling of Tim Sprang watershed in Savara Riverside. So this is a kind of still modeling, but application, but a different model, more of a numerical model and commercial model. They call it Mike Shea, Mike 11, to understand the kind of that watershed was impacted by more than 60 years of a kind of human interventions and associated with laboratory facilities. So there was some chemical waste or nuclear waste from laboratory facilities. So they would like to understand how the impact of those waste. So that's why we used some kind of numerical models. This is something integrated surface and subsurface flow for the Everglades National Park, which is in South Florida. It's similar. We use the same model mainly to develop an integrated surface and subsurface model with drainage water management operations. So trying to provide an assessment of observed and computed time series canal discharge, and also the canal stage within. This is geodatabase development for hydrological model support. This is the kind of as I said, that GIS is a major platform for modeling system. So for that, we have also developed a system where we can reorganize our data, our GIS data that can be an input for the watershed management models. Another project I have is Caribbean coastal scenario. So we have a project in Puerto Rico, Dominican Republic, and Jamaica. I think this program was funded by Inter-American Institute for Global Change, IAI. So I was actually doing a kind of my postdoc in hydrological model. So the main goal was to determine spatial and temporal variability in climate across those regions and simulate the seasonal and interannual flux of freshwater sediment and nutrients to the coastal zones of those 6 watersheds. That is, in fact, a key, very integrated program implemented on those 3 islands. For that was the output of that watershed was used by the decision makers to implement alternative strategies, especially when they plan for development, urbanization, and industrial expansion. Then is how different scenarios looks like. So that's one of this interesting project here. So, as I said, Caribbean coastal region in Puerto Rico, we have 2 watersheds, Rio Manate and Rio Plata. In Dominican Republic, we have Rio Jaina and the Yuna basins. And in Jamaica, we have Great River and Rio Cobre watersheds. The previous Jamaica project are different, another watershed. This is more of Great River and the Rio Cobre. So this is, for example, the model setup for Puerto Rico in land use Rio Plata watershed. So you can see this is a model output for that watershed. Relatively, there's an excellent correlation between the simulated and observed data. This is for one of the projects in the model setup in Jamaica, and also the model result for at later stations of Great River. There are some mismatch, that especially during hurricane, because the model was not able to capture those, but we have a high observed river flow due to high storm during hurricane. And this is some statistical parameters, because for model, you compare your model result graphically and also with the statistical parameters to verify that your model work well or not. This is the model setup for Yuna watershed in Dominican Republic, and this is also one of very good result we have for one of watershed in Dominican Republic in Yuna watershed. You can see there's a very good agreement with the simulated and the measured runoff or stream flow. This is impact of climate change on water access at household level. This is kind of mini project I had with Dr. Armando. Just a small money, but we did a lot of things. Especially we built our collaboration. It was sponsored by Brown International Advanced Research Institute. So we just provide training on GIS and modeling. We have a kind of sharing practical experience with local experts and graduate students here. We had a couple of trips here. And the good thing also, we organized a conference, a very international conference here in Mexico. That was very small funding, but we invited the most prominent scientists from Mexico, from universities, from consulting, and from other non-governmental organizations. And I think Armando was telling me that some of the participants was very senior and high prominent people that attended that seminar. And also Dr. Armando, also he visited us in Florida for Water Information Summit. That was so. It was a kind of that small project helped us to strengthen our collaboration. Yeah, similar project I had for Honduras, watershed modeling in Central America and tropical climate using GIS. and models. In fact, this was supported by the USDA. So I have a kind of a scientist from the name, maybe university guy. It's in Tegucigalpa in Honduras, nearby. So for that, it was a kind of capacity building, and I was just visiting the university for training in GIS, and also that's a local scientist, very good person, and we had built a relationship, research for research and training, and also sharing practical experience with scientists there, and also develop hydrological model for local watersheds. In fact, this is one of my projects, in fact, in Ethiopia, modeling hydrological and hydrodynamic process in Lake Tana Basin, Ethiopia. So that's an excellent program. And just I developed a model for watershed in Lake Tana Basin and use that model to understand the impact of climate change, land use change on the watersheds, and also the downstream lake. And I was trying to see what's happening within the lake using coupling watershed and downstream hydrodynamic model. And I published several papers out of this project. This is some of the model results there. And this is a kind of simulated sediment transport. And that's a very perfect match between the model simulation and observed sediment concentration. And this shows correlation between monthly distribution of rainfall discharge and sediment yield, especially, I mean, sediment has high relation or correlation with the intensity and amount of runoff. That also contribute for the rate of erosion. This is also using the model and the GIS. We try to identify the most erosion sensitive areas in the watershed. That's very good because that's really helpful decision makers where to implement the most appropriate soil and water or watershed conservation strategies. So to identify where are the most sensitive areas in that watershed. Yeah, you can see it very well. This is also trying to see the climate change projection for that watershed to understand how the precipitation or rainfall and temperature trend in that area. Climate change impact, because once you have the changes in rainfall and changes in temperature, you can also quantify how that change can have an impact on your surface flow, groundwater flow, soil moisture, and so on. So that's why we can see this is a different impact for on different hydrological components. We also decoupled watershed and hydrodynamic model to understand the lake hydrodynamics, like the velocity factors and so on. And we compare also measured and simulated water level in the lake because we're able to simulate the lake fluctuation with response to inflow and outflow from the lakes. That's coupling two modeling system, the watershed model and the downstream hydrodynamic model. So this is just a kind of a little bit I was, because some of the things were more technical, so I was trying to say a little less on those topics. But what do we do here? Because we have a lot of experience we develop internationally in Africa, in Europe, in Latin America, in Caribbean, in the US. So how do we collaborate here? So I was talking to Dr. Armando. So there was a lot of water-related issues also here in Mexico. So how do we also leverage from our already existing collaboration? So one thing maybe we can also collaborate in teaching and curriculum development, and also kind of, usually curriculums are revised as per the demand and also the changes in policies, especially depending on how the government policies, how the world look like, how the other experience from other institutions. So we can collaborate as curriculum development. We can also teach or develop new courses if and so that we can use the good thing that Mexico and especially Florida almost Mexico is closer than Florida than like other northern states, you know. So we can still this collaboration also can help us really work together on new courses or teach existing courses, and also even co-teach with some of the already local professionals here. And research, and as I said, that we have small projects, but we did a lot of activities with Dr. Armando's team, his graduate students now, and so this is also the good time now to work together and to find research, to identify research problems, especially now water is a big issue in Mexico, and especially the high population growth, and also so it will be good. It's good time, you know, to sit together and identify problem areas and look for opportunities, look for funding that we can still uh, collaborate and share our experience and contribute for the need of the society. And I see that still there's a huge demand here, in especially in water resource and environmental protection. So that will be one area of collaboration. And we can also publications. That's we have been doing earlier. We published one book, I think, out of our activities, and now we can also continue also doing some research with existing research or with our previous having also our previous research output, and that is also one way of collaboration. Other one, good collaboration also to support graduate students. For example, we can co-supervise graduate students and share the experience what we have. That is one way of also quick collaboration that we can build. And consulting also is a good experience. For example, we can work on projects, development, and other activities as consulting. And also, I'm also dreaming that we can have also kind of build a kind of international or local conference here in Mexico that involving different stakeholders, different mm, professionals from different, not only from university, but from the public, from non-government organizations, from the government even, that with small funding, we can make it a kind of annual conference or biannual conference every 2 years or every year, depending upon the grant or the funding. But that is the best way of, collaboration that we invite people, local experts, international experts, and share experience on a kind of common goal, especially in unintegrated water source management and climate change so on. So that will be some of the ideas I just uh, thought about, and also maybe you are welcome also to suggest any possible ways of collaboration, how we can continue doing things together and to maintain our already existing cooperation, and but to strengthen what we have in our hand. That's what I see. And if you have also, I think, yeah, thanks so much. Yeah.
I have two questions. The first one is about have you used the IPCC scenario?
Excellent. That's a good question. Yes, because especially when I see the projected changes in some climate variables, that's my main uh, major source of information from IPCC, because you cannot just use any variable for climate change, because there's already protocol uh, designed by IPCC that they update every year, every 2 years, or every 5 years. That how climate change, how temperature trend will be in the next 50 years, 100 years, and how the precipitation, especially precipitation, is the most challenging uh, parameters to forecast. But especially for the temperature, they have really very good indication how the temperature will look like. So for that climate change related project, my main input is from IPCC. Yeah.
So thank you. Another question. Water is going to become very scarce in the next decades at the worldwide level. So it's extremely important to make models uh, like these ones and to have an integrated approach. Congratulations about that. Um, Regarding the forecast and the precision of the forecast, I saw that some of your forecasts have confidence intervals and the other ones do not. Why is that?
Yeah, there's no, I mean, maybe I didn't present everything here, but anytime, any prediction, that to build, I mean, you have to make an assessment. You cannot just, modeling is not input and output. It's not something you just put input and just run it and output. So you have to verify it. And especially to build very confidence in your work and your model prediction. One way I show that graphical comparison. The other one is statistical comparison, like coefficient of determination R square, or there is in hydrology NAFSH self-cliff efficiency, or person bias, or also for during an uncertainty analysis, we use this confidence interval, that how confident you are um, on your modeling output and so on. So that's the key, actually, by the way, statistical parameters for verification of your model output that that you build confidence to use for decision making. Especially once you develop the model, what's next? The next is that people can integrate that tool at analyzing long term huge data set. So that's the advantage of using the model. I mean, before we have the model, also our old engineers, our previous, our maybe or our fathers were still using engineering in other applications by, simple calculation. But they did great projects still. But now, after we have this capability of modeling system, that is also to have more platform, make things easy to analyze the past and the future and so on, with having with uh, built-in system for a particular watershed environment or agroecological system.
Okay. So thank you for your responses. Tomorrow we will have a course that Professor Shimelis is going to teach tomorrow about how to use this kind of tools at the lab too. So you are invited. I don't know if someone else have a question.
Well, first of all, welcome to Mexico.
Thank you.
My question is, during your experience here in Mexico and the collaboration and all the work you have done here, what limitants have you identified in the databases that we have here on modeling some kind of study of or some kind of work for your studies?
Thank you. I think that some 10 years ago, I think with the Angel and some of his Dr. Armando's graduate students, we try to also implement some of my model for some watersheds. I forget now the watershed names. It's, yeah, I think so. There was close by, and he told me that there was one priority watershed that we need to develop a model for that. But there was some data limitations for that watershed. And I see in Mexico that we have a lot of data, but there is no good platform or system that you can easily go and get it. Now, what I learned in the US now, that they have really arranged their data, especially their environmental data, their watershed data, even also the company I'm working with is a very big, build a system that was even that was launched public, that the companies, they collect data every hour, every day, and so they put a kind of quality control. After that, they approve it, they publish it. So you can whatever, whether for research purpose, for a development, for the consulting, for anything, you have access that data. And I hope nowadays maybe things might have changed. I don't have a current situation, but 10 years ago here it was an issue to get those data here in Mexico. So that's it. Now, the future, if we have a kind of opportunity and project, that's what we need to really focus. One way of collaboration that to really try and create a kind of platform that can be used to accumulate and store the data, environmental data, water resource data, meteorology data that can be easy accessible for researchers, consultants, public, and government, and those data can be used for decision making. So you cannot do research, you cannot do even development work without data. I saw in Africa they build dams without any verifiable data, and maybe after some time you see that maybe there's no water for that dam, or there are some environmental issues. So whatever, whether it's for construction or for any development activities, you depend on quality data. So that is by itself, collecting, analyzing, and storing data is a big issue everywhere. And that's one way of our possible interventions into the future.
Okay, so thank you very much.
Thank you, Dr. Shimelis. Nice to see you again. I'm Deborah. Yeah, do you remember me? Oh, yeah, sorry. I'm sorry. Yeah. Well, welcome to come to the Institute for Economic Research, and I congratulate you for your magnificent conference about the integrated water research management, and also as Dr. Armando said, you are welcome to our two-day course about HIF. The course is presented by the Dr. Shimelis, and thank you so much. Well, yeah, thank you. We have a gift for you. Yeah.
Thank you.
Well, yeah.
You know that I love coffee, so. That's good. Yeah, thank you. That's beautiful. I love that. Thanks so much. Okay.